Hello, and thank you for watching. My name is Orion Fisher. I am a new PhD student at the Narrative Intelligence Lab at the University of Kentucky, and I am presenting on exploring regression-based narrative planning, work done jointly between Stephen G. Ware and myself. In this presentation, I hope to motivate why regression will be useful to narrative planning, and intentional narrative planning in particular. I will cover the concepts which are fundamental to understanding our regression algorithm, briefly discuss the problems it can solve, and demonstrate the example problem used in the paper. In the paper and this presentation, we demonstrate our algorithm with the Treasure Island problem. In this story, the characters of interest are Jim Hawkins and Long John Silver. There exists a treasure buried on an island, and the characters start at a port in a different location. In the narrative, both Hawkins and Silver wish to have the treasure, though Silver does not initially know that it exists. Silver must be convinced by Hawkins to sail the pair to the island, where either might achieve their goals. Hawkins ends up with the treasure in the end. Narrative planning algorithms search for a sequence of actions that tell a believable story. We examine the case of narrative planning with intentionality. A valid narrative is one where the story is sensible according to the domain and the author's goals, and the characters act to achieve their desired outcomes according to their held beliefs. We build upon a narrative planning model used by Shervani, Farrell, and Ware in Combining Intentionality and Belief, Revisiting Believable Character Plans. In our adaptation, the author and characters of the story are agents with beliefs and intentions. Beliefs represent what agents think are true about the state of the world in some moment, or beliefs about the beliefs an agent holds. There is no depth limit imposed on this theory of mind, so it can capture deeply nested beliefs about other agents in the story. Agents also have intentions. These are goals which they wish to see met, and they will only act in pursuit of these goals. The actions in the final plan must be explained for the characters who take them, in each case appearing in that character's plan to achieve their personal goals. In the Treasure Island domain, this diagram shows the possible paths through the story. The beliefs of the characters, indicated here with underlining, update with the story or specific actions like the rumor action. At the start of the story, Silver has no reason to act because he has no belief of treasure. After he becomes aware of the treasure, both he and Hawkins can imagine a world where they get the treasure. The author's influence decides the true outcome. Many planning methods have been adapted to narrative planning, but forward state search persists as one of the most used. Also called progression, this method starts with the initial state of the problem and attempts available actions, generating new states in the search for one which satisfies the goal. In our case, it is not enough to do this alone. The planner must also ensure that actions used are only taken if they could lead agents to taking them to accomplishing their own goals. Silver will only sail Hawkins to Treasure Island if Silver believes it will give him the chance to get treasure. This restriction requires the planner to search for a usable plan and then check if the actions will be consented to, potentially backtracking the entire search, or to oppose a limit on available actions, restricting the set in each state to those which appear in plans achieving agent goals, but potentially planning around actions the author will never need to use. Alternatively, regression planning is a backward search from the goal proposition of the problem. The search identifies actions that would be useful for reaching that goal, meaning that the effect of the action achieves some portion of the goal proposition, and nothing in the effect or preconditions would prevent using the action just before the goal needs to be achieved. Each time this is done, it produces new propositions. Search is complete once the initial state satisfies one of these goal propositions. Regression is underrepresented in classical planning and is not performed as well as forward search in that domain. However, we believe it is well suited to handling the additional constraints of narrative planning. Regression is goal-oriented, and by starting at agents' goals and working backward, we consider the needs of other agents at every step, building up plans which are explained by nature. At every step of the search, we will only need to find or create a connection to an existing goal for some agent in order to expect their participation in some action. In addition to this straightforward benefit, this method of exploration limits our reasoning to only those states which could reach the goal. In this way, we search a reduced space of propositions, but we also generate an expansive and reusable understanding of how our goal could be met in our specific problem, since we understand states by propositions they satisfy rather than the features that they have. Other authors have explored alternative ways to improve narrative planning outside of forward state search by adapting classical planning research to the narrative planning problem. Partial order causal link planning has been used to model agent intentions as links similar to causal links. Constraint satisfaction has been used to allow authors to specify elements of continuity in the story while maintaining abstract roles. Answer set programming has been used to provide a versatile approach to narrative planning that can account for attention, belief, and themes. We move now to our example. As we perform our search in this problem domain, the actions available to the character and author are of prime importance. As we see here, Hawkins can communicate a belief about the treasure's location to Silver. This is done by taking the rumor action, where Hawkins, as the consenting character, spreads a rumor that the treasure is buried somewhere on the island. Hawkins is only able to do this if he believes the treasure is buried somewhere on the island. This is captured in the preconditions. He will only consider doing it if he also believes that spreading the rumor to Silver will give him the chance to get treasure. This is captured in the concept of explainability rather than the action itself. For the sake of brevity in the coming demonstration, we will use this concise abbreviated form. If Hawkins and Silver find themselves at port, they can reach the island by cooperating. The sail action encodes this interaction, where Silver can take Hawkins to the island if they are both at port. If Hawkins finds himself on the island, and he knows that treasure is buried, he can dig it up with the dig action. If Hawkins does, it is not immediately in his possession, and he will have to lay claim to it with a different action. Finally, the two take actions give Hawkins and Silver the ability to make this claim. They must be on the island and must have access to the treasure, at which point they can take it into their possession. With these actions in mind, we move on to the algorithm itself. We start the regression with the simplest possible plans, the empty plans where we need to do no work and the goal is immediately achieved. As such, we start with the initial nodes in the search. The author hopes to find a state where the treasure is with Hawkins, and Hawkins hopes for the same thing, but Silver wants to find one where the treasure is with him. Over the course of this example, we will use these abbreviations and others to save space. We are not constrained to starting our planning process with any particular agent, so here, for ease of explanation, we will start with Hawkins, but the end result will be the same. Turning our focus to Hawkins' search space, we start the main loop of the algorithm by non-deterministically choosing an action that has an effect which is useful for accomplishing Hawkins' goal. The take action is one possible selection here, considered useful since its effect satisfies Hawkins' goal for the treasure to be with Hawkins. We select the action. Next, we will regress our goal proposition over the action. To do this, we will start with our goal proposition. We remove from it the effects of the take action. We have already found a way to satisfy this part of the goal. Then, we add any preconditions the take action required. We can only execute this action if we can satisfy these preconditions. We simplify this to get our new goal proposition. We must also consider the consenting agents for this action to make sure they will want to take the action. However, since Hawkins is the consenting agent, we skip this step. Hawkins has already concluded that he has good reason to take this action. So we have the new goal proposition, which is abbreviated as so. We continue planning with the author. As we saw before, take is a useful action for this goal. So we will perform hard-to-fix regression over that action. As we saw before, we get the new goal. The treasure is on the island and Hawkins is on the island. However, this is insufficient to capture the needs of this regression, because it does not account for the participation of the consenting agent. Hawkins is the consenting agent, and as such, we need to find an indication that Hawkins will consent to the action. To do this, we non-deterministically choose a goal in Hawkins' search space that the action would provide a useful effect for. As we saw with the previous step, this is Hawkins' final goal. Notably, we do not make use of the regression that we have already performed, a restriction that prevents circularity when satisfying actions with more than one consenting agent. Just as before, we will get the goal, treasure on island, Hawkins on island. However, now this is what Hawkins must believe to be the case, because Hawkins will take the action if, and only if, he believes the necessary conditions will be satisfied and thus lead to his goal. This is incorporated into the author's new goal as a belief of Hawkins. Hawkins must believe the treasure is on the island and that he is on the island, or he will not take the action. If he is right, then he and the author can both achieve this goal, which we abbreviate as so. Moving along with the search in the author's space, we consider the dig action, which requires that the treasure is buried, that Hawkins is on the island, and that Hawkins is willing to take the action. The dig action will have the effect of putting the treasure on the island, unearthed, which is useful for the author's goal proposition. We select the action. As mentioned, Hawkins must be willing to take the action, so we will choose a goal from Hawkins' goal propositions that the action will be useful for. After applying each regression, we get the author's next goal proposition. Here, it should be noted that the implicit effects of the action have been removed from the author's goal. If Hawkins digs up the treasure, he will know that the treasure is on the island, so we no longer need to include this in the preconditions concerning his beliefs. We applied dig in Hawkins' search space as well. And for Long John Silver, we expand his version of the take action. We anticipate the dig action in Silver's search space as well, accounting for Hawkins' beliefs, just as we did for the author. Moving on, we trim the search space here just for ease of depiction. The other goal propositions still exist in the search space, but we will not need them for this example. From the author's perspective, we have already partially achieved our ultimate goal. The initial state satisfies the goal of the treasure being buried on the island. However, we must still find a way to put Hawkins on the island and must continue to keep track of all other requirements as we do. We consider the sail action. It will achieve our goal of getting Hawkins to the island. But we must satisfy all preconditions necessary for Hawkins and Silver to take the action and expect to have a shot at getting the treasure. For Hawkins, just as we will for the author, we will remove the effect of Hawkins being on the island and add the preconditions that Hawkins and Silver are both at port. For Silver, we have found a way to satisfy the requirements that Hawkins is on the island, Silver is on the island, and that Hawkins believes he is on the island, and must add the preconditions. We create the new goal proposition, requiring that all these beliefs align at once, and that the state of the world support them so that the actions will actually be able to be executed. Notably, in order to consent to sailing, Silver must believe that Hawkins believes the treasure is buried somewhere on the island. Without this requirement, Silver would not be able to expect Hawkins to consent to digging, and, as a result, would not have a plan to get the treasure, and thus no reason to sail. In a similar way, we can add the sail action to Hawkins' plan. We have implicit consent for Hawkins to take the action, so we only need to gather the necessary preconditions for Silver's cooperation. Coming up on the end of the search, our solution almost matches the initial state. The author's latest goal proposition only differs from our initial state in that the Silver is aware of the treasure. We can satisfy this goal by the rumor action, which Hawkins will wish to take in order to satisfy that same part of his goal proposition, which will result in our final goal proposition, having removed the requirement of Silver's belief in the treasure being buried and added a requirement that Hawkins believes himself to believe the treasure is buried. The need for Silver to believe that Hawkins believes the treasure is buried is also satisfied by the rumor action because of the implicit effect that those who observe the action become aware that the preconditions of the action that do not otherwise change are in fact true. The last step is to check if this goal proposition is satisfied in the initial state of the problem. We can now see that 3 facts about the world laid out in the initial state are satisfied, and that the character beliefs are what we expect, including that Silver does not need to know where the treasure is. Each of these beliefs is consistent with the world as described, so we can confirm the initial state satisfies this goal, and we have found an explained narrative plan for solving this problem. As we have seen, actions are only added once they are intentional for all characters that need to consent, which reduces the search space to only those plans which are fully explained, and simplifies the search process in comparison to forward state planning. Once this is further explored with heuristic search methods and other optimizations, we expect this to significantly outperform other methods. It also only considers the necessary fluents for the problem and only the values we need to be concerned with, which may reduce the effort needed in more complicated domains. And in particular means that despite the limitless theory on mind that we described before, only those beliefs that are key to the problem will have our attention. Over the course of the search, many intermediate goal states are found, with explained plans leading to the goal already in place. This is useful for the search itself, but may also prove useful in interactive systems where replanning would need to occur frequently. Thank you for watching. We will now take any questions.